Okay, so we're up to lesson 12. All right, guys, we're almost through this unit. We're really close to all the reviews. But this is an application lesson of all the stuff we learned about rate of change and the initial value. And now we're going to put it into word problem form. And this is how the questions will come at you for the state tests as well as the algebra regions. Guys, anything you're learning now can also be on the algebra regions. Okay. So, let's take a look. Word problems. Real life word problems. All right, you've done a lot of work with relationships involving two related variables. However, many real-world relationships involve three or more variables. For example, consider this situation. The 8th graders are selling t-shirts and hats to raise money for their end-of-year party. They earn a profit of $5 per shirt and $10 per hat. This situation involves three variables: the number of t-shirts sold, the number of hats sold, and the profit. The profit for the fundraiser depends on the number of hats and the number of t-shirts sold. What equation shows how the profit P is related to the number of shirts sold and the number of hats sold? So let's kind of common sense it. The profit would equal, well, what did we say the cost of them were? $5 a shirt, $10 a hat. So I would have $5 times the number of shirts, right? Plus $10 times the number of hats. We good? So if we had to write this with variables, profit is 5S plus 10H. So let's try it. Find the profit if each student sells 30 shirts and 50 hats. So it will be, the profit would be 5 times 30 plus 10 times 10 times 10. 5 times 30 is 150, plus 10 times 10 is, I'm sorry, what did I write here? 10? Oh, they show 50 hats. I wrote the wrong number. 50 hats. 50 times 10 is 500. It's a lot of money. So add that together, it's $650 profit. Okay, let's do it with this one. The profit here would be 5 times 15 plus, there's 10 of them times, and 10 hats. So 5 times 15 is 75 plus 100, and this one comes out to be $175 profit. Okay, so kind of simple, right? It's real world, it's common sense, it's how you would find by just substituting. You could, depending on who sold what and how much. Now, the problem may go on to say, if they need to make a profit of $1,000, how many of each shirt do they need to sell? And that's where I think we are heading, kind of problems. All right. Okay. Let's look at the top here. The equation relating P, profit, S, shirt, H, hats, represents every possible combination of t-shirts, hats, and profit values for the fundraiser. Suppose the class sets a goal, the profit they want to be $600. Finding combinations of t-shirts and hat sales that meet this goal requires solving an equation with only two variables, the shirts and the hats. Write an equation that relates the number of t-shirts and the number of hats sold to make a profit of $600. So, just like I said the page before, here's my goal, $600. But on the right side, we know that hats were $5 each, $5 times S, plus $10 times the hats. Find three pairs of solutions to that equation, to the above equation, and then graph them. Okay, now this is where, guys, some of the easiest ones here is if you decide, make one of the values 0. In other words, don't sell any shirts. If I sell no shirts, How many hats would I have to sell? Be 60, right? And vice versa. Sell no hats. How many shirts would I have to sell? 5 into that goes what? Oh, I forget now. We'd have to divide it out. 5 into 600. Do you get how I'm showing you this? So you could make combinations here that will work. And it has to work. You want the numbers to be able to be graphable. Okay? So let's try it this way. So we've got shirts, comma, hats. We'll pretend that's X and Y. So let's think about this. Shirts and hats. If I sell zero shirts, so that would be gone, and it would be 10H equals 600. What is H? How many hats does that have to be? 600 divided by 10 is 60. Make sense? Do vice versa. I sell 0 hats. 0 hats. No hats are being sold. Gone. How many shirts do I have to sell? 600 divided by 5, and I believe is 120. So now watch. This is amazing. I go to my graph. The lines are very light. I hope yours are darker, but we can find it. Okay, bottom is t-shirts, and here's the hats. So this is hats, not caps. Hats and t-shirts. Okay, let's figure out where I can put these coordinates. 0, 60, 0, 60. So hats, I've sold 60 right there. Did not sell any t-shirts, so that's where that dot goes. The other one is 120, 0. So t-shirts, shirts, 120, zing, 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 zing. I got to get all the way over to 120. And this graph did not go far enough. It would be out here. Sorry, guys. Even maybe a little bit farther. That's annoying. Okay, and then I would connect the dots, providing I had the proper graph set up, and unfortunately, guys, all right, and this would be at 120. Okay, now I can do combinations. Let's see if this works. If I sold, let's do 20. If I sold 20 shirts, so 20 shirts, one second. Okay, sorry, a little interruption there. Okay, so what if we sold 20 shirts? Then the question is, how many hats would I have to sell? Because I want to get to the 600 total. So if I sell 20 shirts, and the shirts are how much each? $5 each. So I'm looking at $600 would equal 20 times 5, right? Plus 10 times the H. Well, 20 times 5 is 100. So it'd be 600 would equal 100 plus 10H. Well, subtract the 100 off the 600, right? So I would get 500 would equal 10H. So how many hats will I have to sell? The number of hats would have to be 50. So if I had 20 shirts, I got to sell 50 hats. Now, let me show you how this works on the graph. I go over to 20 shirts, and I take my line, I go up. Oh, bingo, what are we at? 50. So wherever it's crossing the vertex is the combination. 40 shirts, I'd have to sell 40 hats. If I sell 60 shirts, I'd have to sell 30 caps or hats. If I sell 80 shirts, I'd have to sell 20 of the caps. If I sell 100 shirts, common sense here, 100 shirts, 100 times 5 would be 500, and we still got to get how many? 10 more, 10 hats. So there's your group of your combinations here. Okay? Why does the graph only occur in the first quadrant? Because we're talking about real things, no negatives, real things, and real money, which is only positive, which is quadrant 1. What do the coordinate pairs mean to the context of the word problem? It's the combination of hats and shirts sold. Isn't that a good one? So that's where we're heading with all this, with our equations. This is a linear function, believe it or not. This is a table of, okay, how's this going to work? The best way to do these kind of problems is make one 0, figure out what the other one would have to be to work the equation, make the other one 0, figure out what the other one would have to be. And that's how you plot them, right on the axis, on the y-axis, on the x-axis, and you make your line. And there's your combinations. I like doing these. These are fun. Even though my dog is snoring, he must find this very boring. Max, max, max. Okay? Let's try this one. Okay. Students in Eric's gym class must cover a distance of 1,600 meters by running or walking. Haha, there's our two variables, running and walking. There's our total. Most students run part of the way and walk part of the way. Eric can run at the average speed of 200 meters per hour, so he's running at 200 meters per hour, okay? And he's walking at an average speed of 80. So I'm taking the facts out. So 80 meters per minute. This is per minute. Sorry, guys, per minute. This is a minute up here. Oops, per minute. Okay, thank goodness it's the same. We wouldn't want to start converting. Okay, so the question says, if Eric runs X minutes and walks Y minutes, so here's his, they're using X, so X is going to represent the walks, the walking time, and Y is going to be, so we have to kind of like say let X be the walk and Y be the, I'm sorry, I keep making mistakes, guys. X is not, X is the run. X is the run. Eric runs for X minutes and he walks for Y. Sorry. Write an equation for the total distance that Eric will cover. Well, we know his rate for each one of them, okay? So his running rate is 200. So it'll be 200 times X plus his walking rate is 80. It'll be 80 times Y. And what does it have to come out to be? 1,600. Okay? Similar to the hats and t-shirts. Suppose Eric runs for 4 minutes, so he's running for 4 minutes, and walks for 8. Will he reach his finish line? So now I substitute 200 times 4, because the X is the run, plus 80 times 8. And the question is he going to make it to the 1,600 line? 200 times 4 is 800, plus 80 times 8 is 640. If I add 800 and 640, I believe I get 1,440. Does he make it? No. Now, the question says, find 3 pairs of solutions to your equation that will work in that equation. Okay, so 200x plus 80y, I want it to be 1600. So x, y, run, walk. All right, if x is 0, he does not run at all. If x is 0, this whole thing goes away. Then what's my y? It would be 1600 divided by 80. Well, guys, just do some simple math here. Isn't it 20? So he has to do 20 minutes. And now flip-flop, change the other one. Go 0 on the y. If the y is 0, this goes away. And I have 200x equals 1600. So now I have to divide by 200, right? Divide by 200. Guys, simple math. 16 divided by 2 is, x would have to be 8. Make sense? Okay? So if I had to graph these, this one would be up on 20. So if I sketched a sort of a graph here, this one would be up here at 20, and the other one would be at 8. And I would just connect the lines that way, and then I could see my combinations. So let's just kind of guess one. Let's say x is 4. What's 4 times 200? 4 times 200 would be 800, right? So 200 times 4 plus 80y equals 1600. Let's just do that. This is 800 plus 80y was 1600, right? Take it off the 800, take off the 800. 800 away from 1600 is 800, so it would be 80y would be 800. Divide by 80, divide by 80, dot, dot, right? What do you get? Y is 10. So y would be 10. So there's your 3 combinations. 3 pairs of solutions that would work in that equation. So, easy. The best way to do it when you get to this far and you have to pick out ones, make one of the variables 0, figure it, solve for the other, then do the other. The other variable 0, solve for the other. Make sense? Okay. Next part is the homework. And here's our homework. So I'll do this with you, I think.